The next couple of days here, we're going to start getting into two new shapes. We're going to talk about surface area of a pyramid and then surface area of a cone. For today, we're just going to focus on pyramids, and then the next day we'll talk about cones. Okay, so we're going to kind of separate it, but we put them together because these two shapes are very similar in how they look. If you know what a pyramid or a cone looks like, it's different than what a prism or a cylinder looks like. Remember when we talked about prisms and cylinders, those shapes had two bases, and then they had all those faces in between that connect the bases to each other. A pyramid and a cone are different in that they're going to have a one base instead of two, and then all the faces that the shape has are going to kind of come up and meet at a point. So you can kind of see that over here on my picture, where the bottom here is going to be your base. So like this shape is going to be the base shape, and that could be a rectangle, a square, a triangle. It could be a regular polygon. It could be any of those things that we've seen in the past. And then this point here at the top has a special name. This is called the apex. And that's just the point where all those faces kind of converge and they make this point. Now, when you're working with a pyramid and a cone, we really want to be careful that we understand where the height of this shape would be. We've talked a lot about height in the past and how you can't have a slanted side be your height. So when you think about a pyramid or a cone, the sides of that shape naturally slant downward, okay, if you're starting at the top and you're going down. So we would never use one of those sides as our height. Instead, our height would be on the interior of this shape. So I'm just going to draw it. And it would come like way down to this base, and it would make a 90-degree angle there. So this would be the height of my pyramid. And that same thing is going to happen when you're dealing with a cone. There will be times for certain shapes that we have to use what's called the slant height. The slant height is going to be one of those sides of the pyramid or cone that is going down at the angle, okay? So we'll kind of get into when do you use the true height and when do you use the slant height. So let's get into what a pyramid's definition is, because so far we've defined what makes something a prism and what makes something a pyramid. For a cylinder. For a pyramid, this is a solid with one base and triangular faces. And the number of triangular faces is going to depend on the size of your base. The larger your base shape is, the more sides that it has, the more faces that your pyramid is going to have. So like we've been doing with the other shapes, we've been dealing with their nets. We're going to still talk about the net for a pyramid. So your pyramid net is going to look a little different because how we kind of did it with the cone, or sorry, I keep saying the wrong shape. When we do the prisms and when we do the cylinder, we kind of had the faces, like the shapes that connected the base, to be in the middle. So like for your prism, you had a bunch of rectangles. For our cylinder, we had a big long rectangle. And then your bases were on either side. So the bases of the prism or the circles from your cylinder. When I do my net for my pyramid, I actually like to put the base shape in the middle. So when I look at this first one, I like to actually look at my base, which is going to be this shape down here, the way bottom, and I like to put that in the middle of my net. Now it looks like, according to this one, that all the sides here are the same. So this base would actually be a square. And then for my other parts of my net, I'm going to draw those faces. Now all the faces are triangles. So you're going to have a triangle that comes off of each side of your base. And so I'm just going to draw all of these triangles coming off of those sides. So that's what your net would look like. Now, if we start to have actual numbers, like we did with the prism and with the cylinder, we're going to continue to go in and start adding those numbers so that eventually we need to start finding area of all these little shapes and being able to add them up. Now, the big difference here is that you're only going to have one base. So remember when we did like a prism, if we had like a triangular base, we talked a lot about how you don't have to divide by 2 because you're doubling the amount of bases. That's not going to be true for these pyramids. So we will want to make sure that we're careful about working with our shapes. Do we need to divide by 2? And make sure that we're calculating it appropriately. Okay. But why don't you guys, for both B and C, take a minute here and try to sketch the nets for those 2 different shapes. Okay, so I'm going to start sketching these nets out. Now, letter B, your base shape is a triangle. So I start with the base, and then off of my base, I need to have those faces. So each side should have another triangle coming off of it. Okay, so that one looks like that. And then for C, what shape is your base for this one? A hexagon, right? Because it's got 6 sides down there. So I'm going to draw out my hexagon first. And then we're going to draw those triangles off of each side of my hexagon. So it should look something like that, okay? I don't expect your nets to be perfect, just like with the prisms and the cylinders. You know, you're sketching a net, do the best you can. It doesn't have to be perfectly to scale or anything like that, okay? Even mine are not maybe the most clean nets, but you get the idea of like kind of what's going on here. So now what I want us to start doing is actually start finding surface area. So like we did with the prisms when we started out on Tuesday, when we were actually finding our surface area, I'm going to draw my net first, and I'm going to start labeling it with the numbers that they give me from my 3D shape. So we're going to start with this first one. When I look at a pyramid, the first thing that I would do is just recognize what kind of shape is your base. Okay, so if you guys look at this picture of this first pyramid, what shape is the base here? It's the rectangle, right? Because it's an 8 by 6. So it's not a square. This time it's a rectangle. So I'm going to start by drawing that out. It's an 8 by 6 rectangle. Okay, and then from each side, there's going to be these triangles. So I need 4 triangles. Okay, so there's my net, and now I'm going to start labeling things. So for my rectangle, this side would be 6 and this side would be 8. Okay, that's just from my base. Now, if you take a look at the other numbers that are in there, those are talking about the triangles that are on the edges. And they're giving us these heights for each triangle. Now, they're giving us 2 because there's 2 different triangles that we're seeing here. This one with the 8.5, that's coming off of the side that would have 8 as its base. So the side of the rectangle that's 8, which would be like the top and the bottom of my picture, these heights of these triangles are going to be 8.5. And so that's going to be the same down here, 8.5. And then the other triangle, the one that has a base of 6, what are they saying is this height? 8.9, right? So I'm going to put that here, 8.9, and this would be 8.9. So let's figure out how we would find the area here. And again, like we did with our prisms, let's split it up into the different shapes that we see. So let's start out with the rectangle first. So remember, to find area of your rectangle, it's just base times height. So we're going to just do 6 times 8. So that would come out to be 48. Okay, so that's this interior piece. That takes care of the rectangle here. This is all 48. Now there's two different triangles because they each have their own base and they each have their own height. So let's start with, I'm going to just say triangle number 1. And I'm going to do this one. The one with a base of 8 and a height of 8.5. How do we find area of a triangle? You take base times height divided by 2, right? So we're going to do 8 times 8.5. Okay, and then you would divide by 2. But how many of these triangles are in the picture? There's 2 again, right? So we've kind of talked about this in the past that I can actually just double that, or we've talked about how when there's more than one, and when there's like an even number of them, we don't have to really think about dividing by 2 and multiplying by 2. That's a little bit of like doing the same math. It's just extra steps that we don't need. So we can just take 8 times 8.5, and that'll take care of these two, the top triangle and the bottom triangle. And so this would be equal to 68. Now we're going to do the same thing for the other triangle. I'm going to call that one triangle number 2. I'm going to write it down here. Triangle number 2, the base is what number this time? Good, 6. And then the height of that triangle is the 8.9 again. Good. And again, you would be dividing by 2, but then you're doubling it. So you don't really need to do this. So you don't have to write this out. You don't have to write out the divide by 2 times 2. I don't need to see that. If you understand what's going on here, that this triangle is, there's 2 of them, so we're doubling it. If you like to find each individual shape and fill them all in piece by piece, then you will want to make sure that you're dividing by 2. Okay, so this comes out to be 53.4. So your last step then is to add up all of those individual areas. So the 48, the 68, and the 53.4. We need to add all of those up to find my total surface area. So I'm just going to write that underneath my blank here. And so if you add all of those up together, you should have 169.4. And then this would be inches squared. So that's your final answer. Okay, so really look at your pictures carefully and make sure that you're using the appropriate numbers when you're labeling your picture and when you're starting to plug it into your formulas, okay? So let's take a look at B. I want you to take like a minute here and I want you to just sketch your net out and label it all. And then if you're ready to even like keep going, you can, but I'll come in here in like a minute and make sure that our nets look the same, and then we'll start solving this one. Okay, I'm going to start drawing out my net. Now this time your base is a triangle, so I'm going to start there. Okay, and I'm going to go ahead and just label what I can on my triangle. So I see that the sides of my triangle are all 6. So this is actually like an equilateral triangle. They're all 6 because it shows like 6 and 6 here. Oh, hold on. Yeah, no, am I thinking that right? I think so. And then my height in here, they're saying is that 5.2. Okay, so now I'm going to add on the other triangles on the outer edge. Okay, and so it's showing that, yeah, it's showing that all the bases are 6 here, so that inside triangle is equilateral, and then the height of one of these triangles, like the faces, they're saying is 10.1. Now that's going to be the same for all of these outer triangles because the base is a regular shape, so all the faces are going to be the same triangle as well. It was different on the rectangle because that's not a regular shape. The rectangle has 2 different lengths for its base and its height. And so one of those triangles is going to be bigger than the other 2 triangles, okay? When you're dealing with a regular polygon as your base shape, those outer faces are all going to be the same triangle because they're going to have the same base, and then that would mean they have to have the same height. You can't, especially if it's a pyramid and they all have to meet at that top point, one of those triangles is not going to be bigger or smaller than the other ones because then there would be either a gap, like one of them wouldn't close the pyramid, or one of them would be way too long and there'd be like a weird overlapping happening at the top. Okay, so all of these triangles on the outside are going to have that height of 10.1 and they're going to have a base of 6. Now we need to figure out the area of all the triangles respectively. So I'm going to talk about the base triangle first. So I'm going to call that triangle number 1 is my base. And there's only one of those. So we have to use our formula as normal. Base times height divided by 2. So that's going to be 6 times 5.2. And then you're cutting that in half, dividing by 2. And so that's going to come out to be 15.6. Okay, so that's my base. I'm going to write that down underneath here too, 15.6. Because I'm going to have to add that to the triangles on the outer edges. Now, all of these on the outside are equal, so let's call those triangle number 2. What's the base and the height of those faces? Yeah, 6 is the base, 10.1 is the height, and you're going to divide that by 2. But how many of those triangles do we have in our picture? We have 3 of them, right? So I have to take this amount times a 3. I'm going to squeeze that in over here because I'm running out of room on that side of my page. So to find the bases, I need to take 6 times 10.1, cut that in half, and then I have to multiply by 3. I do not think it would be easier for you to like do these individually, or like try to figure out a way to like cancel that 2 off the bottom. We were only able to do that on the other one because there was double. And so that was easy to do that simplification. You're going to want to just take 6 times 10.1, divide it by 2, and then triple that number. Okay. And so this is going to come out to be 90.9. And so we're going to add 15.6 plus 90.9. And so my total surface area here is going to be 106.5 inches squared. All right, we've got one more that I want us to get through here for just pyramids today. So if you guys turn your page over, there's this last one. Okay, what shape is your base for this one? The hexagon. Okay, and it is regular. We said that when we're dealing with these polygons that they're going to be regular polygons, like a regular hexagon, regular octagon. Like I'm not going to throw like a really weird hexagon at you guys. Okay, so this is similar to the one that we just saw, but the base has changed. Our base is now a little bit bigger. So there's going to be more faces, but since it's a regular hexagon, that means that all those faces are going to be the same. Okay, so let's go ahead and draw our net here. I'm going to draw it over here to the right where I have a little bit more room. I know it's supposed to go down here, but I don't think I have enough space to put my whole figure there. Okay, so there's my base shape, and then I got to put on my triangles on each side. And again, do your best with that. Okay? What do we know about the hexagon? Yeah, we know all the sides are the same. How much is it? 6. Okay. And what else do you know about the hexagon? You know that apothem length. Whoop, what just happened there? Okay, the apothem is 5.2. All right, now what do you know about the triangles? Base is still 6 for all of them. What's the height of the triangles? Okay, 13.1. All right. Obviously, my picture is not drawing the scale. Okay, those triangles should be a lot taller than my hexagon is. All right, let's just go with it and pretend like everything's fine. Again, I'm not going to care if your pictures do the same thing. I'm not worried about if you're drawing it to scale right now. That's not what I'm focused on. So let's do this. How would I find the area of my hexagon? Use that formula we've talked about, right? Apothem times the perimeter divided by 2. What's the apothem of your hexagon? 5.2. The perimeter would be what? 36, right? Because it's a hexagon, so there's 6 sides, and then it should be times another 6, because that's how long they are. So 36 is our perimeter, and then we're going to divide that by 2. What do we get when we do that? 93.6. Okay, so that takes care of the base, the hexagon. Now let's talk about the triangles. So what is the base and the height of your triangles? Good. 6 is the base, 13.1 is the height. We would divide that by 2 for our formula, but how many triangles do we have? 6. And again, we know that they're the same because this is a regular shape. Okay. Now, you could do a little bit of simplifying here if you wanted. You could see the 2 could make this 3 or 6 become a 3. So you could do that. That works out better than the last one did. Okay. And what do you get for an answer here for all those triangles? Okay, 235.8. And then the last step is to add. What's 93.6 plus 235.8? Good, 329.4. And then we're back to centimeters squared. There's your final answer. All right. Hopefully that makes sense. We're not adding a ton of new stuff here for the pyramid. I mean, I didn't throw any brand new shapes into the pyramid. I mean, the pyramid's new, but like the shapes that make up the pyramid, you've dealt with those before. Be really careful with your triangles, that you're paying attention to their measurements, paying attention to the base and whether it's regular or not. That'll tell you kind of what you need to do with your triangles. Okay? All right, like I said, this is where we're going to stop because the cone is next. And so we'll pick up on the cone the next day we have class.